Hi, everyone. I'm the MapR product manager for data science and batch analytics. Today, I'm going to talk to you about how to distill actionable insights from your data. To begin, we want to talk about this. Let's talk about how data science teams enter, or how teams enter into data science. So there are many different types of data science teams, many entry points into the data science journey. According to recent reports from both Gartner and McKinsey, about 80% of companies are still only in the experimentation phase or earlier in this journey. Surprisingly, machine learning and artificial intelligence are only deployed into production about 12% of the time. Of that time, nearly all of these cases are in the tech sector. In a McKinsey survey of 3,000 AI-aware C-level executives, only 20% said they currently use any AI-related technology at scale or in a core part of their business. McKinsey identified that seamless data access, technical capability, and leadership from the top were the key enablers of these successful data science strategies. So let's start talking about seamless data access. There's no doubt that the more data you feed a model, the more accurate it's going to become. A single variable model can be trained on a small data set. Every variable or feature that you add to this model multiplicatively increases the amount of data that you need to maintain accuracy. Model variables can be direct, like the price set for a particular color of paint, or they can be flags set in how something performs in comparison to a reference competitor. More data lets you make smarter guesses. And this isn't exactly headline news, but there is massive growth in the amount of data that is being generated, stored, and processed. Beyond the sheer amount of data, the diversity of this data presents new challenges. It's machine data, sensor data, videos, social media, comes in the form of CSVs, Parquet files, JSON. And at the time when you figure out your data capture strategy, you might not know what questions you're going to ask later. It's critical to avoid siloing your data based on type or convenience because there's a chance that you won't be able to access all of the silos in the same way later. This can lead to non-random sampling. If you're only sampling 2/3 of the data, it really matters what third you leave out. So if it's all about the data, then it better be about all of your data. That's right, it should have come up already. And after you've solved all of your data access problems, you still need to keep checking that you're doing things right. Ongoing model validation is a consequence of more data coming in. In order to test two models against each other live, you need to leverage replicable and replayable streams. What this means is the ability to replicate the pipes of data coming into a model such that it also goes to a competing model, and the ability to replay a stream later to check for consistency and for accuracy. So at MapR, we've tried to provide a solution to all of this with our Converged Data Fabric. We pair industry's only persistent global streaming capability with a multi-model document database and exabyte-scale data store to give you seamless access to historical, operational, and real-time data. Many of our competitors are accomplishing similar feats by patching together disparate partner solutions and services. Our vision for intelligent processes highlights convergence and innovation, and we have the experience to assist leadership in developing a roadmap for intelligent processes that can help them derive new insights and value. But what's the point in building such a great platform if you can't leverage it? Last year, we began a foray into containerized client containers with a Docker image that allowed for native platform access. This was called the MapR client container. MapR persistent application client container, sorry. Yesterday, we announced that we were going to be expanding this with our data science offering called the MapR Data Science Refinery. These are persistent containers that can directly read and write to the platform, leveraging all platform assets. They can be run on a laptop or an edge node. They can be run from a tiny instance in a cloud. And they can be delivered as a pre-configured image to tenants. All security is handled by the container itself, which frees IT up, and all notebooks are stored to the file system, allowing containers to be spun up and killed off with no loss of data or work. The MapR Data Science Refinery delivers everything a data scientist or engineer needs to log in and get to work. This includes access to Spark, Hive, Drill, Python, in addition to all of the converged platform assets like MapRDB. This is also extensible and open, so you can stop by the booth and see how to run Tensor Flow, reading and writing directly to your file space in the cluster. So by extending our Docker file to include Tensor Flow, I was going to do a demo of this, but those tend to fail in live situations. So I'm just going to show you what it looks like and encourage you to come by and see it live. But what we did was we extended our Docker file to include TensorFlow, and then users are able to run TensorFlow in the container, all of the dependencies satisfied on data that's sitting in the cluster. Results and changes are stored directly back to the cluster itself in a persistent way. So imagine the possibilities here. It's the ability to test any new algorithm or library in isolation on data that exists in your global namespace. Of course, the compute is limited to the memory available to the container, but this is just a first step to allow further exploration into containerization at MapR. So here's another one that we're doing live. So let's say I'm trying to predict the propensity of churn for my company's customers. In order to do this, I have to accomplish 3 tasks. I need to create a data set that contains information which can be used to predict churn. I need to develop a machine learning model that uses the features in that engineered data to predict churn. And I need to be able to use those models to analyze how my business is performing. To accomplish this, I need to have access to my customer database, click streams, and raw data files. Our data science refinery makes this possible in one visual space. Now, as you can see here, I've taken sections of paragraphs because when you scroll down this, the actual code to do each of these tasks is pretty long. So what we've highlighted in this demo, which I'm happy to walk you through, we actually have the live code, is we're reading and writing to Spark. We're reading and writing from MapR event streams through Spark streaming. We're writing that data to Spark RDDs and then storing it as JSON into MapRDB. We're reading this data back. We're doing machine learning on it. And we're using Spark SQL. We could also use Drill here to provide some imagery and some reporting on this data. The thing about Zeppelin is this is all available in one visual space. And when we ship this container to customers or when they ship it to their tenants, all of the configuration is already done. The only thing that is done is to pass some parameters into the run command on Docker. The security is handled that way. All of the cluster settings, so essentially you roll this out, you hand this off to a data scientist. They start it up, they log into Zeppelin, and they start submitting work. That work goes to the cluster. The security has been handled. They have access only to the data they're supposed to have access to. So what we say at MapR is that we believe that 90% of machine learning is data logistics, not learning. So recommend, I have about 15 of these books left. Is a book by Ted Dunning, focusing on model logistics, particularly an abstract way of handling model deployment that he's termed the rendezvous architecture. It's a way to persist 2 different models and input streams to those models, along with a canary model to track model degradation and a slight proposal on how model monitoring can improve in the future. So if you want to stop by the booth and be scanned, I'm happy to give you the books as long as they last. And I realize I've only used about half of my time, but I'm sure that our next fellow here will be happy to take it. So thank you very much.